Hello everyone, welcome back to another developer session. Last time we left off, we had just implemented a fairly nice little loading corridor, which disguises our unloading and loading of new levels and assets without using a loading screen. So, just for reference's sake, you can see in this scene here, I have this indoor area 1 as well as this loading corridor loaded up in the hierarchy view. And as I enter my corridor, you can see that indoor area 2 is loaded in addition to area 1. And then once we come back up here into area 2, area 1 unloads completely. Now, last time we'd come into a little bit of a stumbling block where models or particle effects or audio data or other information that is exclusive to one level and not the other needs to be accessible via our object pooling mechanism, but needs to also load and unload based on the other scenes that are loaded in. So I did that little bit of development off camera because it involved quite a bit of research and experimentation. And I did the part for the object pooling. We still have a few other parts, which one of them we're at least going to go through today. But the basic idea for the solution is we have this object pool dictionary, which we've been using for quite a while up until now. And it keeps a list of a key-based lookup of object pools that are loaded into the scene. Each pool representing a model or particle effect or some other bit of data which whose number of instances need to be controlled and recycled so that we're not wasting CPU cycles on allocation and deallocation of repeatedly used memory. So this guy is staying in our gameplay object scene, which represents all the items that are common to the battle and menu system and player movement and things of that nature. And in our individual level scenes, we have a new component that's added called a object pool dictionary appender. And this appender has a series of pieces of metadata that keep track of the keys that we're referencing in our lookup, as well as the prefab and other information like our starting and maximum allocation capacities and whether that capacity is allowed to increase if the demand is exceeded. And at runtime, when we load our scenes, our first scene that gets loaded up is our gameplay objects, which we do a full load scene. So the the objects are actually run through their activation. They're awake and their start cycles are done. And then our subsequent levels are added in, which this object becomes activated as a part of. If we'll look at the code here, on start, it goes and makes sure our metadata is appropriately filled in, and it goes and grabs the poll dictionary that's registered with our IOC container. And using that registered item, it adds our metadata to the dictionary. Now, when we add the item, here's one of two things that'll happen. So either the item is completely brand new and it's not in the dictionary at all, and we're going to go ahead and create a new object pool manager with its own object pool and fill in all of our capacity information and prefab information with the metadata that's been supplied. Or the item's already in the dictionary, in which case we're going to increase a reference counter. Now, alternately, when we close the scene, for instance, when we go through the loading corridor and we unload the previous level, its object pool appenders are going to send a call to remove that key from the object pool dictionary. Now, when that remove is called, we're going to check that reference counter and decrement it. And if the reference counter is 0, we know that there are no loaded scenes that reference that type of object anymore, and it can be released from memory. And the reason for the reference counter is in the scenario where we have more than one scene loaded that utilizes the same, for instance, the same enemy model, or maybe two scenes share a similar, the same background music. We only want to unload those assets when none of the scenes that are in memory are actually referencing it. And that seems to work pretty well, though we haven't really tested the reference counting aspect of it. So that's the first thing that we're going to go ahead and do right now. So I'm going to grab this object pool appender, and we'll make a quick little prefab out of it. Let's go ahead and pop over to our indoor area 2. And we'll just go ahead and pull this object pool appender in here. Now, I'm going to go ahead and, for the sake of testing, I'm going to add some debug.log statements here. Let's go ahead and come back to our initialization scene. And once we load this in, once we get to the loading area, we're going to see that our reference counter is should be 2 anyways, assuming this code actually works. So let's just get on over there. Let's see here, yeah. So there's our log statement with our reference counter equal to 2. Now we're going to go ahead and expand out the game objects scene and take a closer look at our object pool. Now, when I enter area 2, we should have the the object pool in question, which is the one for our rabbit enemy. The pool should remain because it's loaded up into both scenes, which it did. And there we are back in here. Though we did get a little debug.log error. What happened? Game object has been destroyed, but you are still trying to access it from spawn unit. Interesting. And it seems our enemy model failed to load. And I'm assuming that error, that error occurred again once the level 1 loaded in. So let's take a little bit of a look here. So what's going on? Get available item is looking at the pool first or default item that is not active in the hierarchy. Well, we got this guy here. Our indoor area 1 enemy spawn location has nothing because naturally those things don't exist. However, our enemy objects did get created. The model placeholder is empty. So why were those objects destroyed? That is interesting. Well, the object was destroyed because the object was moved to our enemy, to the enemy that was spawned when we first loaded in. When we unloaded that area, that enemy was destroyed, including the model that was originating in the pool. However, because our pool remained the same, we have, even though we have one game object underneath here, it still is holding a reference to a 3D model that has been since destroyed, hence the error. So how do we want to solve this? If I remember right, in our object pool, we hook onto the enemy killed event, which isn't actually happening since our model is being destroyed. Our enemy isn't actually being killed via via our actual gameplay rules. So that event's never going to fire. What we need is that on destroy in our model, we need to return it to the pool. So let's take a closer look here. So we do our set model, and he's given the key for the model we're going to use as well as the transform to attach it to. We do our get available item, and what else goes on in here? Placeholder is given the object. The placeholder doesn't know anything about the object pool though. But via the enemy, we know about the object pool, or rather the key at least. So we can use the object pool dictionary to get the actual pool based on the key and do the return to pool for the model. So that's one way to go about it. Or we can simply use this remove model method that apparently I wrote at some point, which does exactly that. And that happens from the battle manager when we actually end the battle. Does this guy appropriately null check everything? Sure does. Okay. So let's go ahead and just try this out here. So enemy should have an on destroy already set up. And he should also have his model key. Yeah. So let's go ahead and see what happens. And I'm also not sure exactly what repercussions this will have on our normal battle system. Shouldn't be any. Yeah. Alright, so now that we've unloaded, we should have in our object pool 2 items. Alright, good. So it returned back to the pool. Now when I return back to the first level, yeah. So there we go. Now, as you probably observed, there is an issue where every time we reload the level, the enemy spawn completely resets, which naturally would not be our desired behavior. We would want the information to persist, through level transitions, assuming these weren't actually spawned enemies, but just enemies that were already placed. We would want to do some kind of very quick runtime serialization to keep track of all the enemies that were spawned in the level, as well as their rough positions. And then when the level was returned to, we could start from there. But, that's kind of a problem for another day. It's a little bit out of scope for what we're trying to do right now. So it seems like we solved that issue, and that looks good. So let's take a look at the prefab dictionary. Hang on, though, we have another error. But that just happened when I closed the scene, so I'm a little bit less worried about that. What's this? Object type, object pool manager has been destroyed, but you were still trying to access it. And that's from when I do the remove item. Naturally, because of the way the scene's unloaded, the call to remove happened after the first scene had already unloaded. So that's purely an issue of stopping the editor. It's not a real error. So anyways, back to business. we have our prefab dictionary, which we may or may not need to apply a similar mechanism to. So what do we have in here? We have some prefabs for our QTEs. We have some prefabs for our enemy objects, but these are super lightweight. Like, what is this? Simon says attack all QTE. What does this actually have visually that's interesting? It literally just has a script attached to it. And what else is in here? Enemy combatant. Yeah, these are all very lightweight, code-only prefabricated objects. Is there a scenario where these would actually need to be set up? Actually, there's no scenario right now in which we're using this prefab dictionary for anything other than incredibly lightweight objects. So I'm not particularly worried about these being more of a global repository rather than something that's appended to on a scene-by-scene basis. So there's that. I want to touch audio as a completely separate part because we haven't really talked about audio too much. Particle effects are already part of our normal pooling system. There's not really much we can do as far as level-based texture data, since that's going to be applied to the objects in the scenes themselves and not globally accessible. So I think as far as our loading corridor goes, that covers all of our bases. So we'll go ahead and call this here. Thank you for watching and have a great day.